Good day everyone, I'm John Vincent B. Ocab and welcome to my presentation on microwave link design, a point-to-point terrestrial communication system project designed between Ligao and Malinao, Albay. This project demonstrates the process of designing, analyzing, and evaluating the performance of a microwave link using engineering calculations and software tools. This is the table of contents, and first is the main objectives of this project are: first, to design a point-to-point path profile for a microwave communication link. Second, to establish a terrestrial microwave link between a transmitter site in Ligao and a receiver site in Malinao. And lastly, to align this design with the Sustainable Development Goals, particularly SDG 11, the Sustainable Cities and Communities, SDG 5, Gender Equality by promoting safe, inclusive, and resilient infrastructure. To begin, I conducted the site selection and path profiling using Google Earth Pro. I first identified suitable transmitter and receiver locations that comply with zoning and accessibility requirements. The total path between Ligao and Malinao is approximately 10 kilometers. Using Google Earth's elevation tool, I analyzed the terrain to ensure a clear line of sight free from any obstructions. Then, I exported the data to Microsoft Excel to compute parameters such as earth curvature, Fresnel zone, Fresnel clearance, and total antenna height. Finally, I used Excel to generate a path profile graph and a power level diagram and apply link budget formulas to verify the reliability of the design. The transmitter site in Ligao was placed behind local houses away from residential structures but close to a highway and a power supply, making it both accessible and safe. The receiver site in Malinao follows the same principle behind residential areas and a road with a stable power availability. This setup ensures both technical efficiency and community safety. In this elevation profile, you can see the terrain variations across the 10-kilometer path. Although there is about a 255-meter elevation difference between the sites, the design ensures that the 60% Fresnel zone clearance is maintained. This is critical to avoid diffraction losses caused by terrain or vegetation. The design parameters as follows. Frequency is 6 GHz, distance is 10 kilometers, bandwidth is 30 MHz, tower height is 30 meters, antenna height is 25 meters, and the type of tower is self-supporting tower, and the antenna diameter is 1.5 meters. These specifications ensures both high performance and high stability. Now let's discuss the microwave link budget which determines the expected signal strength and reliability of the link. First is the transmitter power. The transmitter power is 35 dBm and with an antenna gain of 36.895 dBi and a line loss of 1.0125 dB. The effective isotropic radiated power or EIRP is 70.883 dBm and the free space path loss is 128.012 dB. After considering receiver gain and losses, the received signal or RSL is minus 21.247 dBm. The calculated fade margin is 62.982 dB, which represents the link's resilience to fading or environmental interference. Next is the system reliability. Based on these calculations, the propagation reliability of the system is approximately 99.999945%. This means the system is expected to operate reliably for all but a few seconds per year, well within the standards for carrier-grade microwave communication system. Next is the power level diagram. This diagram illustrates how the signal power changes as it travels from the transmitter through free space to the receiver. You can see that despite losses along the path, the receiver signal remains well above the required threshold, ensuring clear and stable communication. In conclusion, this project successfully achieved a reliable 10-kilometer microwave link design between Ligao and Malinao. Through proper path profiling, accurate budget calculations, and effective site selection, the system achieved both technical excellence and sustainability. With a fade margin of 62.982 dB and a system reliability of 99.999945%, the design demonstrates the capability of microwave technology to support dependable long-distance communication links, contributing to modern, connected, and sustainable communities. The design was on verified data and references, including equipment specifications from Cambium Networks, Sabre Communications, and Andrew RF Connectivity Resources. And these are all my reference. Thank you for watching my presentation.